His screen is visible? Yes?
Yes, it's visible.
Voice is clear now?
Yes, yes, sir.
Okay. See your second chapter, sets, functions, sequences, and sums. Unit 2. It is a sets, functions, sequences, and sums. Okay, coming to first the definition of set. Set means it is a collection of, a set is a collection of, a set is a collection of well-defined objects, collection of unordered, you write like this better. A set is a unordered collection of, a set is a unordered collection of well-defined objects, collection of well-defined objects. Now in this set definition there are two important points. One is unordered collection, another one is well-defined objects. Okay, what is the meaning of first thing? Ordered collection or unordered collection? Ordered collection or unordered collection? Generally sets are represented by by the flower brackets. Sets are represented by the flower brackets. For example, say example 1, sets, this is capital A, notation of a set represented by capital letters. If I take A, E, I, O, U, set of ovals. What is this? A set of ovals. Now everybody say, for example, in your class, for 40 members are there. Each member of your class said, what is this letter? First letter? What is the first letter in the set?
A.
A.
Is anybody cannot say it is not A?
No.
No. That means this object is well defined. This object is well defined. For example, if I write, for example, I will write like this, something like this, E, I, O, like this. What is this? The first object and this fourth object? Anybody identified?
Not defined.
No, right? That means this first object, fourth object are not well defined. These objects are not well defined. Well defined means meaning is what? It must be recognized uniquely by everyone. It must be recognized uniquely by everyone. That is so called well defined objects. And another word, ordered collection. What is the meaning of ordered collection? Ordered collection means, see, this is idea. What is this A comma B?
Order pair.
Generally you said this is the point, correct? Right? A comma B is a point, right? Which is also known as ordered pair, which is also called as ordered pair. Ordered pair. And if I write like this, what is this one? This is AB. This is nothing but set. This is called unordered pair. Whenever I use this flower bracket, this is called unordered pair. Unordered pair. And if these are in this set, there are only two elements. That is why it is called a pair. And if I use this flower bracket, that is notation for unordered pair. If I use this open brackets, that is the notation for ordered pair. Therefore, a set is now, if I write like this, for example, if I write 1, 2, 3, this is called what? Unordered collection. The unordered represents what? Set symbol.
Excuse me, sir.
Yeah.
Someone is waiting, sir. To join the class.
Generally, after 2, I will not allow anyone.
Okay.
Okay, from tomorrow onwards.
Okay.
Now, 1, 2, 3. This is called ordered collection. Unordered collection. If only 2 elements are there, that is called unordered pair. This is the definition of unordered collection and well-defined objects. So set is defined as it is a collection of well-defined objects, and that collection must be unordered collection, not ordered collection. Ordered means you write open brackets, open a comma b. Set examples, you can create any number of examples. And what is this natural number set? What is a natural number set? 1, 2, 3 and so on up to infinity. And what is a set of integers I or z? What is a set of integers set? 0 is there, 1, 2, 3 up to infinity, and -1, -2, -3 and so on up to infinity. Okay, nothing but one can write this set as 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. This is set of integers. Set of integers. Similarly, you write rational number set, generally represented by q. What is a set of rational numbers? Rational numbers notations are, the elements are p by q form. P by q form, p comma q belongs to z, and another condition is denominator not equal to 0. Another condition, denominator. That means just q never 0. If it is 0, it goes to infinity. So any fraction, whatever it is, minus 1 by 2, 1 by 2, 1 by 3. You may write 1, 2 also. 2 means 2 by 1. 1 means 1 by 1, like that. You can, whatever it is, minus 100, like that. These are all rational numbers. These are all rational numbers. Okay. Next one. Examples of this one. Okay, now see, this natural number set is there. What is this set? Number of elements are what? Infinite. Number of elements are infinite. Is these elements are countable? Yes. For example, this set of integers. So many elements are here. In a set, each value is called an element. Each value is called an element. Now, is this set n countable, or I countable, or q countable? Anyone?
No, sir, it's uncountable.
What is the meaning of not countable? Why you are saying it is not countable? What is your idea in your mind?
We don't know how many elements exist in that set. It can go to any extent.
Yeah. Okay, that is your idea, na? Let me see. Now, let me count the values of integers. See, what is integer set? Z equal to, what is this? 0. I will write like this, plus or minus 1, plus or minus 2, plus or minus 3 and so on, correct? Okay, you are thinking that since these elements are infinite, it is not countable. It is not countable. It is not like that. It is not the definition of countable or uncountable. See, I will count every value here. See, what is this first 0 element? I will take this as first element. 0 as first element. In plus or minus 1, how many elements are here? Plus 1 is there, minus 1 is there, correct? So I will count this as second element and third element. Same logic, plus 2 and minus 2 terms are there. Fourth element and the fifth element. Similarly, plus 3, minus 3. This is sixth element and this is seventh element. Okay, like that I can count. Any counting problem, anybody?
No, sir.
Now, is it possible to count even though these values are infinite? For example, plus or minus 100 is there somewhere. Plus or minus 100. Plus 100, minus 100. Plus 100, I will count this as 101 and this as 102. Why? Because 0 is taken as 1. 0 is taken as 1 means 100 is taken as 101th term. Like that, I can count plus or minus 1 crore, plus or minus something, whatever that element is there, I can count. So, what is the meaning of countability? Countable set means, see, each element of a set is assigned by a natural number, which is not repeated. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 101, 102. That is, therefore, the set Z is the set Z is countable. The set Z is countable. What is the meaning? Once again, countable means if a set contains infinite number of elements, it doesn't mean that the set is not countable. What is meant by countable set? Every element, each element of a set must be assigned by a unique natural number, which is not repeated natural number. 0 is assigned by 1, plus 1 is assigned by 2, minus 1 is assigned by 3, like that. This is called countable set. Okay, and number of elements in the set. Next one, the number of distinct elements. The number of distinct elements in the set is called, this is called cardinality of a set. Is called cardinality of a set. Cardinality of a set. It is denoted by number of elements in A, or simply this symbol. The symbol indicates the what? Not mod A. Mod is exist for values, not for sets. Remember, mod, this is called cardinality of A or number of A. This is another definition of a set combination. Next one. And one more is what? Elements. This elements is the element. The objects in the set are called, the objects in the set are called elements, are called elements of the set, are called elements of the set. This is another definition. And next one. Now, can you tell, therefore, natural number set, set of integers, set of rational numbers are countable sets. Are countable sets. Okay. Now, set of real numbers. Set of real numbers. What is the notation for set of real numbers? Set of real numbers is denoted by R, right? Denoted by R. Now, can anybody tell what are the elements in R? Generally, in textbooks, R is taken as minus infinity to infinity. Isn't it correct? Right?
Yes, sir.
But now see, like natural number set, this natural number set, set of integers, set of rational numbers, let us list the values of real numbers. Okay, I'm taking 0. After 0, what is the next real number?
1.
1. Why not 0.1? 0.1 is also real number, no?
Yes, sir.
Right? If I write 0.1, someone raised, why 0.1, sir? 0.001. Right? It's also real number. Why 0.001, sir? It may be some 0.000000 something. I don't know. What is that number after immediate number after 0? Can you list? Can you write?
Yes, sir.
After 0, what is the next real number? Can you imagine? No, it's impossible. So 0, between 0 and 1, infinitely many values. Between 1 and 2, infinitely many values. 2 and 3, infinitely many values. Like that. Same logic. Minus 1 and 0, infinitely many values. And minus 2, 0, infinitely many values. Like that. If I want to list the set of real numbers, it is like this. It is like this. Between any two natural numbers, there are infinitely many values in real numbers. So we cannot write each value, each element of the real number set. So it is represented by like this, minus infinity to infinity. This is one idea in set theory. And next one, yeah, equal sets. Next definition. See, these are all definitions. Remember, cardinality is one definition and elements is another definition. Okay. Countability is another definition. Now equal sets. Two sets, when equal sets, two sets A and B are said to be equal, if elements of A and B are same. Elements of A and B are same. Elements of A and B are same. That is elements of A and B are same. That is, you write like this. That is, for all x belongs to A, if and only if x belongs to B. For all x belongs to A, if and only if x belongs to B. Then we write A equal to B. We write A equal to B. Okay. What is the meaning of this for all x? You know, predicate calculus. Universal quantifier. For all x means universal quantifier. X belongs to A. What is by implication truth table? You know now? P. Okay, I will write like this. What is this? P, Q. P by implies Q. This is the truth table. What is the truth table? True, 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 false, false, true, and false, false. And a false, false. When P by implies Q is true, yes, when both are true, when both are false, isn't it? Correct?
Yes, sir.
Right? This is the truth table. So I need this. Now for all x means for every x, if x belongs to A, if and only if x belongs to B. Meaning is what? If there is an x in A, then there must be x in B. If and only if means vice versa. What is this? P by implies Q is equivalent to what? P implies Q and Q implies P. Q implies P. Therefore, if x belongs to B, then there must be x belongs to A. If there is an x in B, then there must be x in A. That means elements in A and B are same. Then those are said to be equal sets. A equal to B. A and B are same, and we write A equal to B. For example, if I write A equal to some x, y, u, and B equal to, I will take u, y, x. Yes, values are same now. Just order is changed. It doesn't matter. Here, if x belongs to A, then x belongs to B. What is this x now? Okay, right. Doesn't matter. You write like this. Here, elements of A equal to elements of B. Elements of B. Therefore, A equal to B. A equal to B. Now, another example. A equal to x, y, z. B equal to u, v, w. U, v, w. Both are same equal sets. Here, elements. Here, elements of A not equal to elements of B. Elements of B, right? Therefore, A not equal to B. A not equal to B. But, say, I'm giving another definition, but number of elements in A equal to number of elements in B equal to 3. Nothing but cardinality of A, cardinality of B equal to 3. Then, elements are different, but number of elements equal. Then, I mean, you write like this. If number of distinct elements, number of elements in A and B are equal or same, then A, B are said to be, the sets A, B are said to be Previously, elements are same means we call them as equal sets. Now, only number of elements are same, then A, B are said to be equivalence sets. Equivalence sets. What is this? A, B are said to be equivalence sets. This is the deviation between equal sets and equivalent sets. Equal sets and equivalence sets. Another one. Coming to Venn diagrams. Notations. First one, universal set, like real number set. Universal set is represented by U. Universal set is represented by capital U, and its Venn diagram is represented as a square box or rectangle box. Square box or rectangular box. Now, one more definition. This is one more. An empty set. An empty set is denoted by null and is defined as phi equal to empty set means there is no element. This is the notation for empty set. A set which does not contain any element is called an empty set, and its notation is phi. And one more definition. A set with a single element. A set with single element is called Singleton set. A set with two elements, what is it is called? Anybody? A set with two elements. Just now I told you at the beginning. A set with two elements is called, set with two elements means what? In brackets, that is, what is this one? I told you already. Is called unordered pair. Ordered, not ordered. Unordered pair. Is that clear? Okay. Just inka gurtunchukovadaniki meeku logic cheptanu. We have anyway in the last unit graph theory chapter is there. Graph theory. Okay. So I will give one simple notation to remember ordered pair and unordered pair. In graphs, this, what is this is ordered pair. This is called ordered pair. Represents that there is an edge. From the vertex A to vertex B. Meaning vertex means dot, vertices A and B, and there is an edge or bridge at vertex from A to B, not from B to A. That means what? There is a path from the vertex A to vertex B. That is the meaning of ordered pair. Same logic I will give unordered pair. Flower bracket, unordered pair. This is what is this is called unordered pair. Unordered pair represents that there exists an edge between A and B, between the vertices A and B. What is the meaning of this one? A, B, two vertices are here, and there is a bridge between A and B. That means I can move from A to B as well as from B to A. Whereas in this one, this one ordered pair, I can move from A to B only, not from B to A. This is graphical representation of ordered pair and unordered pair. Okay, this is the main difference of ordered and unordered pair. Now, coming to another one, subset definition. Subset definition. A set or A రెండు combination వస్తుంది కాబట్టి you write like this. The set A is said to be subset of B, subset of another set B, if and only if IFF, if and only if notation IFF or by implication, if and only if every element of A is also an element of B, is also an element of B, is also an element of B. That is, if X belongs to A, there is an element X belongs to A, then X belongs to B. If X belongs to C, said to be subset of B, if every element of A is also an element of B. Meaning is what? If X belongs to A, then X belongs to B. Then we write A, this is the notation for subset. Then we write A subset B. Then we write A subset B. This is the definition of A subset B. And let me clear one more definition also. Proper subset. Proper subset. The definition looks like same, but the change is same. The set A is said to be proper subset of B if A is subset to B and A is subset to B. First of all, A must be subset to B, and there exists at least one element in B which does not belongs to A, which does not belongs to A. Okay, and we write A proper subset B. Notation is only this: A proper subset B. A proper subset B. No, this line symbol. Previously here subset, proper subset, and this line is there. Here that line will not be there. Now this definition is clear by using this example. See, I will take A equal to some 1, okay, 2, 4, 6, 8. And if I take B value as, okay, let me complicate this. Indirectly I will write X such that X is divisors of 8. X is such that the symbol is such that, okay, X is such that X is divisors of 8, and B is what? 1 to 10. 3, 4, 5, 6, 7, 8, 9, 10. Then here, what is set A? Divisors of 8 was what? 2, 4. Okay, 1 is also there now. You write 1, 2, 4, 8. 1, 2, 4, 8. Here clearly every element of X, every element of A, that is 1, 2, 4, 8 belongs to B. Every element of A belongs to B. Therefore A subset B is true. Isn't it? First definition is over. Now coming to second definition, clearly there are so many elements. What are those elements? Example, 3, 5, 6, 7, 9, 10. There are so many elements, 3, 5, 6, which belongs to B, but not belongs to A. Therefore, what is the exactly definition is satisfied? See, What is this? Every element of A must be element of B, and there exists at least one element in B which does not belongs to A. Exactly here it is satisfied, but not belongs to A. Therefore, A is proper subset to B. That is, A is proper subset to B of B. This is one example. And one more point. When subset is when the proper subset does not hold, second example, if I write A equal to some A, B, C, simple example I am taking, and B is also I am taking A, B, C. Let me write B, C, A. B, C, A. Here, every element of A belongs to B. And there is no element of B which is not belongs to A. Which is not, there is a no I mentioned here. Therefore, what? Clearly A is subset to B. Therefore, A is subset to B. Same logic. And also elements of B belongs to each element of B belongs to A. Therefore, B subset A, and there is no other element of A which does not belongs to B. Therefore, B subset A. You take this as 1, this as 2, this as 2. And what is this from this? Clearly, what we have? Clearly, these two gives. What are these two sets? A, B, C, B, C, A. Both are equal sets. Equal sets. So, for equal sets, what are this condition? Therefore, for equal sets, if A subset B, remember this, and the connective is and B subset A, then A equal to B. This is the one of the important property where we have to prove some theorems. If A subset B and B subset A, then A equal to B. Okay. Anybody, do you know what is this property? Antisymmetric property. Anyone? Antisymmetric property? No? Okay. It will come in graph theory anyway. Is that clear? Subset concept, subset and proper subset, and equality of sets using subset concept. Any doubts? Yes? Okay. Next concept is the coming to Venn diagram. Venn diagram of A subset B. What is this? Venn diagram of A subset B. A subset B means every element of A belongs to B, and there must be an element in B which does not belongs to A. Always there will be one universal set taken as rectangle. This is universal set. And in A and B, which is the least set? Least set means which contains less number of elements in A and B. If yes, A. So B is the bigger one. So take B bigger set. This is the set B. And every element of A is in B. Therefore, A must be inside. This is Venn diagram of A subset B. And same logic, Venn diagram of B subset A. This is the universal set. And here superset is A and subset is B. This is Venn diagram of B subset A. Okay. And now you tell me, what is a null set?
A set which has no elements.
Null set. Very good. Null set is denoted by phi. Done? Okay. And one more important point. Let me write here. Every set is subset to itself. Is it correct?
Yes, sir.
Yes, sir.
Okay, that means A subset A. Every element of A belongs to A, right? So every set is subset to itself. Okay, and one more important point is also there. Null set is null set is
Subset to every
subset
set.
to every set. Null set is subset to every set. Every set, I said every set. Is it true? What is the meaning of this one? Phi subset to A. Phi subset to A. Is it correct?
Yes, sir.
Is it correct? Here every set is subset to itself. Why? Because A subset A means every element of A, yes, belongs to A. That is why A subset to A. Now coming to here, null set is subset to A. In null set there is no element at all. In null set there is no element at all. Then how it subset to A? Yes? Yes? Anyone? There is a theorem. For every set in textbook, yes notation is used. For every set, yes, null set is subset to S. Null set is subset to S. This is the theorem. Is it the true statement?
Yes, sir.
Then how? Null set doesn't contain any element. Null set lo elemente ledu. మరి ఎలిమెంటే లేనప్పుడు అది ఎట్లా సబ్సెట్ అవుద్ది? Now listen the proof very carefully. Let S be a set. Let S be a set. To prove phi subset S, when we say phi subset S, we have to prove that ఎప్పుడు సబ్సెట్ అని చెప్పాను డెఫినేషన్, if x belongs to phi, then x belongs to yes. Is it correct? I have to prove this statement. Exactly this subset definition I have given here, where it is. Yeah, what is this? If x belongs to A, then x belongs to B, then we write A subset B. A subset B. Exactly. Now I have to prove that statement. Then I will write phi is subset to. Phi is subset to. Yes. I have to prove this now. We have to prove that this statement is true. This statement is true. Shall I start? Okay. Proof is saying let the statement P be. What is meant by statement? What is meant by statement? Yeah, baboy. Statement. First unit andi. A declarative sentence which is either true or false but not both is called statement. Correct?
Yes, sir.
Correct na?
Yes, sir.
So statements are denoted by small alphabets, right? Let
Yes,
the
sir.
statement P be, I'm taking P, x belongs to phi. And let the statement Q be, I'm taking another statement Q be, what is that? X belongs to yes. Right? Then symbolic form or mathematical form. Symbolic form of if x belongs to phi, then x belongs to yes. Symbolic form of is what? P implies Q, isn't it?
Yes,
right?
sir.
If P, then Q. What is the statement? If P, then Q. Agreed?
Yes, sir.
Right. Now, జాగ్రత్త చూడండి ఇక్కడ నుంచి. In P implies Q, in an P implies Q is called an implication. Implication. In P implies Q, P is called what? P is called what? And Q is called what? అమ్మా ఇది చెప్పాలి మీరు ఆల్రెడీ అయిపోయింది ఫస్ట్ యూనిట్ మీకు. P is called premise. P is called premise or hypothesis. P is called premise or hypothesis. And Q is called consequence or conclusion. Consequence or conclusion. Isn't it correct?
Yes, sir.
Correct na? P implies Q lo this first P is called premise or hypothesis, and Q is called conclusion or consequence. Now in P implies Q, now what is actually I will write like this. What is P? P is X belongs to phi. Is it true statement or false statement? X belongs to phi, false statement or true statement? Null set lo elements untaya?
No, sir.
No. So X belongs to phi, is it true or false?
False.
Exactly. Is false statement. Is false statement. Right? Coming to Q is what? X belongs to S. X belongs to S, is it true or false?
True.
True or maybe false also. Ayo, we don't know, right? But X belongs to phi is definitely false statement, and Q X belongs to S is which is definitely true. X belongs to S may be true statement or maybe false statement. Therefore, this P implies Q is there now. In P implies Q, we have what is this one? False implies true or false implies false. Correct?
Yes, sir.
Right? P implies Q. P is false, definitely false. Q may be true, and this which is false implies true is what?
True.
True.
Which is true. False implies false is what?
True.
True. Done. Therefore, what is the given statement? What is this one? P if X belongs to phi, then X belongs to S. Is it always what is the statement? The statement is always true.
True.
Therefore, P implies Q is always true statement. Is always true statement. That is, if X belongs to phi, then X belongs to S is true statement. Is true statement. Therefore, phi subset S is true. Is that clear?
Yes, sir.
Check out any doubts. What I'm taking, I'm using to prove this one. I'm using the implication formula if P then Q, because in subset relation, subset is connected with the if then. So phi subset S, to prove phi subset S, I have to prove that if X belongs to phi, then X belongs to S. So directly I'm taking X belongs to phi as one statement, X belongs to S as another statement. Okay, then the symbolic mathematical.
I have a doubt.
Yeah. Tell.
We said that if X belongs to null set is false, we took it as false, no, sir.
Yeah, I
Then
took
how
false
are we
only.
assuming that we are first assuming that X belongs to phi, no, sir? We shouldn't assume that an element belongs to phi.
No.
Because phi is a null set.
Sir, see. You're not catching my point. To prove phi subset yes, correct? To prove phi subset yes, I have to prove this statement, correct?
Yes, sir.
If X belongs to phi, then X belongs to yes, I have to prove, right?
Yes, sir.
So if statement I have to take first. That means X belongs to phi, I have to consider first.
Okay.
If I consider X belongs to phi, what I'm saying, yes, you are saying it is a false statement now, right? So it is false statement, and X belongs to yes. It may be true statement or false statement. So the statement, this word is mathematically connected as what? False implies true or false implies false. Both gives what result? A true statement. Both gives what result? A true statement, because we have the truth table of implication, right? Both are true. What is this true? False implies true, false implies false. If X belongs to phi, then X belongs to yes. Yes, it is true. Similarly, it is also true. That is what I'm getting. Phi is always subset to yes.
Yes.
Got it?
Okay, sir. Here X is, I mean, we should consider only in terms of Boolean algebra.
In terms of Boolean
Algebra only X belongs to phi is possible, no, sir?
in Boolean algebra, phi is there.
No, sir, but
In Boolean algebra, only two values are there, zeros and ones.
okay.
Don't relate this to Boolean algebra. Okay.
Okay,
Just
sir.
the concept is subset. I'm using just the definition of subset. What is subset definition? If X belongs to A, then X belongs to B, then A subset B. That's it. To prove phi subset A, I have to consider one element in phi, and I have to prove that that element belongs to yes. I'm taking X belongs to phi, which is obviously a false statement. Okay. Then I consider using connectives. False implies true, false implies false. Both gives true statement. Therefore, null set is subset to every set. Got it? Next one, proper subset I told already. Yeah, power set. Next definition is power set. Power set. Definition of power set is, just give me 1 minute. Yeah. Power set. What is the meaning of power set? It is a set. It is a set which consists of all the subsets. Which consist of all the subsets of a set. Of a set A. Which consists of all the subsets of set A. For example, see, example, if I consider A equal to 1, 2, I'm considering only two values, 1, 2. What are the subsets? Subsets of A are, what are the subsets? Null set is subset to every set. Just now we saw. Next one, the element 1. If I take 1 only, see, let me take like this, better. No need. Take this as A equal to 1, 2. If I take A1 value as 1, A1 set is 1. And what is A set? 1, 2. Clearly A1 is subset to A. Correct?
Yes, sir.
So this 1 is subset to A. Same logic. 2 is subset to A. Another one is what? 1, 2. The original set. Every set is subset to itself. Every set is subset to itself. So 1, 2. These are the subsets. Same logic. Second one. If I consider A, B, C, 3 sets, then subsets. Subsets of A are null set, first one. Next, singleton sets, A, B, C. Next one, two element sets. AB is there, another one AC is there, another one AC, BC is there. Another one, the original set ABC. These are the subsets. Now, collection of then power set, for example, then power set of A is, first example, for the first one, it is denoted by P of A. Power set of a set is a set. Set of what? Set of all subsets. I will write like this. Power set of A 1, 2 is P of A 1, 2, 1, 2, 1, 2. And what are the number of elements in power set? Number of elements in power set 4, where number of elements in A 2. Next one. For the second example, power set of A equal to ABC. Power set of A equal to ABC is set of all subsets: null set, singleton sets. Next one, 2 element sets, AB, AC, and BC, and the given set, that is ABC. This is total power set. And what are the number of elements in power set? Number of elements of a power set 4, 5, 6, 8.
8.
Where number of elements in A 3. Okay, therefore generalization, if number of elements in A, I will write like this. If set A has n elements, then power set has
2 power n.
Then power set of A has 2 power n elements. 2 power n elements. Right? Now you tell me, what is the power set of empty set? Question. What is the power set of empty set?
I think it is 1, sir.
Empty set. Empty set is a power set of
1.
What is the empty set? Empty set, how many elements? Number of elements in empty set?
0.
0. So number of elements in power set of empty set?
0.
1.
2 power 0.
1.
1. 1 na?
Yes.
How it is 1? Correct. So what is the power set? Power set of 5. ఏముంటది ఎలిమెంట్? పవర్ సెట్ ఆఫ్ 5. Yes.
5 only.
5 only, exactly, right? Okay, only one element, the set itself to subset. Next question, see, what is the power set of 5, the set 5, power set of set 5. That means what? To get this, let A equal to the set 5. Question would adogochu. What is this one? Like this. What is this set? 5. How many elements in A?
1.
How many elements in A? 1.
1.
So power set of, what is my set? A. 2 power 1. 2 must be there. So what is the power set of A?
5.
5 and set of 5.
5 and A.
Exactly. 5 and A. Exactly. Very good. That is power set of what? This is null set. Is what contains? It contains null set and the given set. Null set and the given set. Yes? Agreed? Okay. If you catch the logic, this one is very easy. Today I will stop here up to power set. In the next class, I will tell about Cartesian product, and next one Russell paradox, and quantifiers for the sets, complements of the sets, then principle of inclusion, exclusion, union, intersection. Anyway, second unit is simple one, very simple. Is this fast is enough?
Yes, sir. Yes, sir.
Okay. I will stop here and I will post the record of this one in my YouTube channel. Okay, you
Sir,
can.
what about notes, sir?
Whatever I have written now, I will make it as PDF and post in group. I will post it in group.
Okay, sir.
Okay, sir. Thank you.